Hi everyone, today we're working by factor by grouping. It's called by grouping because we're going to pick our own groups. We're going to pick our own teams. So here's our example. Let's start factor by grouping. So if I give you a problem from what we've done before, this is from before. If I write x squared plus 6x plus 8, is there anything common for these three values? X squared, x, 8 doesn't have an x, so forget that. I see 6 and 8 are even, right? But x squared doesn't have a even value, so I can't do that. So you see that there's nothing in common here which I can factor. But let me give you another problem. If I write x to the third plus 3x squared plus 6x plus 18, does everything here have something common? No. So this trick called factor by grouping works like for the most part, we're going to see in Algebra 1 if you see 4 terms. Because 4 terms is something that we have not worked on factoring. We've only seen at most 3. So we're going to be able to factor this 4-term problem, but we're going to use a couple of tricks here. Okay. First thing, we're going to break the problem into 2 groups. Look at the front group and look at the back group. Okay. So we're going to selectively look at this group as just look at the front, ignore the back, and then look at the back, ignore the front. So looking at the front 2 terms, what do we have in common with just those 2 terms, x cubed and 3x squared? What do we have in those 2 terms? Okay. So you see an x squared in common, perhaps? We don't have just a regular 3, but we have an x squared in common. So we're going to factor out just the x squared. So I'm going to write x squared. What's left over from the front terms if I take out x squared? If I have x cubed, 3 of them, and I take out 2 of them, we have 1 left. 1, 2, 3. I take out 2 of them. I'm going to factor out 2 of them. I still have 1 left. Hey, this is x squared. It's 3 times x squared. So I'm going to take the x squared. So I'm going to just have a 3 left. So take a look at that, please, for me. Would you guys be okay with me just taking out what they have in common? They both have an x squared, at least. That was our greatest common factor for the front 2 terms. For the back 2 terms, let's go ahead and see what they have in common. Do they have any x's in common? 6x and 18? No. How about do they have a 2 in common? Yeah, there's a 2 and 6 and 2 and 18. Do they have a 3 in common? Yeah, they do. What's the greatest common number that they have in common? Well, 2, 3 are great, but they have 6 in common, don't they? So I'm going to take out, look, there's a 6 and x, and there's a 6 and 3, isn't it? So I'm going to take out the 6 from the back. So I'm writing plus, because I want a positive 6. I'm taking out only a positive 6. And if I take out a positive 6, what do we have left over? We still have please take a look here. We still have an x and a 3 left over. Now, did you notice that this whole problem had an x and a 3 in common? So when we factor out what's in common for the front group and back group, it actually reveals a secret to us. It reveals that the front group and back group had something in common. It just wasn't obvious when we first looked at it. And this is called factor by grouping because we're going to break up our group, factor in a small way, and then see overall, take a step back. Let's take a step back and see, do we have something common now for this whole problem? Folks, do you guys see something in common for the whole problem? Is it x squared? Is it 6? Or do you see in the front group and back group, they have an x plus 3 in common? So what we're going to do now is we're going to say, you know what? We factored in front, we factored back. Now, since I've revealed they both have x plus 3, we're going to factor out x plus 3 for everyone. So if you take a look, I took out an x plus 3. I took it out to the front. We undid that multiplication. So to look at this is x plus 3 times x squared times 6. And this is our factor. We are done. This is factored by grouping. We are still able to make this into binomials, lucky us. But factored by grouping is a type of technique in which we first start off saying, oh man, what do I do with these 4 terms? We're so used to 3 terms, we're so used to 2 terms but we never looked at 4 terms. And this is a special technique done with 4 terms. Let's do another problem. Okay? This one might be a little more obvious, but let's see. We have 13x cubed plus 13x squared plus 4x plus 4. Now, do you see anything common all the way across? Do they all have x's? Nope. Do they all have 4s? Nope. Do they all have 13s? Can we divide them all by 2? No. So I want you guys to break this up into the front group and back group. Take a look at the front group and take a look at the back group. Okay. In the front group, what can you tell me that they have in common? In the front group, what can you tell me they have in common? They both have what? They both have a 13. Huh? They both have a 13. What else do they have in common besides just the 13? Do they both have x's? A bunch of x's with them? So if I can say this, I have x, x, x in the front, as well as x and x. At least how many do we have in common? Well, don't they at least have 2 in common? So let's take those 2 in common. So we have a 13 in common, as well as 2 x's in common, x squared. Now, if I remove those, what do we have left? We have an x in the front, and it turns out we took out the whole 13x squared. So we have to write a leftover 1 as a placeholder. We have to leave that placeholder. If we forget that placeholder, it's going to mess us up later on. Okay, just to make sure, 13x squared times x is 13x cubed, and 13x squared times 1 is 13x squared. You can double check that to make sure you did factor it correctly. Let's look in the back. What do we have in common in the back? That's fine. Schoology was down for everyone. So I think it's still down. Okay. So what do we have in the common in the back? Take a look at the numbers. We have a 4 in common. Do we have any x's in common at all? Nope. So we're going to take out the 4. Now what's left over? If I take out the 4's, we're left with an x plus, careful, 4 divided by 4, because we're undoing the multiplication, is 1. So we have to write 1 as a placeholder. Now that you've revealed this puzzle here, oh my goodness, x plus 1, we can write x plus 1 left over 13x squared plus 4. So we were able to factor this 4-set problem by not just looking at it as an trinomial. We were able to break it into 2 groups, 2 by 2, and then we were able to see, hey, there's stuff in common between the 2 by 2. And then we were able to break that down some more. Okay. So let's do another problem here. Just so let's see these skills of ours. We can see if we can practice these. So 16x cubed plus 8x squared plus 10x plus 5. So take a look at this problem here and let me know, do you see anything in common between the front 2 terms and the back 2 terms? Okay, let's see if you guys can break down this problem yourself. Okay, hopefully that was enough time. Let's take a look at the front numbers, 16 and 8. What numbers are related in 16 and 8? They both have 2, they both have 4, they both have 8. Okay, we'll take 8. Let's take the 8. 16 is 8 times 2, just to see that. And we have x cubed and x squared. At least we can borrow 1, 2, 3. And then we have 2 here. We can take at least 2 from each. So we're going to take the 8x squared from all these. So 8x squared, we're left with 2. See how we have an x left over? And since we took everything, 8x squared, we have to write a plus 1 here. Leave a space holder. In the back, can we get 2x plus 1 also? Well, I see a 10 and a 5. Well, common value is 5 for both of them. So if I take a 5 from the 10, 5 times 2, if I take the 5, we're left with a 2. And 5 divided by 5, we're left with just 1. So 2x plus 1. And hopefully you got the same term in front and same term in back. So as we take a step back, what do we have now in common between the front term and the back term? Okay. What do we have in common between the front term and back term? You got a burger and fries? I got a burger and fries. Hey, we both got the same thing. We got both a burger and fries. What's left over? Oh, you got a milkshake though. Well, that's cost a lot of money. And I just got a Diet Coke. I'm cheap. Okay. So once we take out what's in common, we factored it out. We write down what's left over. So if I take out an x minus 1, if I take it out, I'm left with an 8x squared. If I take out 2x minus 1, I'm left with a 5. And take a look. That's what we have left. We have left an 8x squared plus 5. Okay. So really, that is the skill. If you guys want to practice that on IXL, you guys can get started on that now. I'll do one more problem to help you guys to make sure we're all kind of on the same page here. Okay, so this one just has letters. Let's see. We have yz plus y minus 6z minus 6. Now this one isn't numbers now, but that's, again, we have 4 terms. Let's go and break this up into 2 parts. We have 4 terms to break this up into 2 parts. Okay, so what do we have in common in the front? What do you have in common in the back? Now this one's gonna be a little tricky because we're gonna see something more in common in the back, but let's look at the front. We have yz and y. So would you be okay that they both have a y? So let's factor out the y. If I take out the y, what's left over? We have a z plus, don't say 0, please don't say 0, and don't write nothing. Remember, we're dividing it out. We're taking it out. So y divided by y is equal to 1. We have to write a 1 here as a placeholder. Thank you, as a placeholder. That placeholder is really what's messing us up here. All right, Schoology is working now. Great, perfect. Yes, it was out for everyone. District-wide, actually. Okay, so we took out the y. Now look at the back. I have a 6, but I want you to take a look here. Don't we have a negative 6 in common? So let's take out the negative 6. If I take out the negative 6, the z now becomes a positive, and negative 6 divided by negative 6 becomes a positive. Now, what if I didn't take out the negative? If I didn't take out the negative, we would have left out with z plus 1 plus 6 negative z minus 1. Are these terms alike now? So one of the things that you guys will notice when you're doing these problems is that if they're not exactly alike, you have to find a way maybe to take more. In this case, I probably would have had to take in this case, see how they're both negative in the back? You would have to take that negative with us so that they both become alike. Those like terms are super important for us. Or, I mean, those common factors. These were common factors. So now that we have common factors now, z plus 1, we have y minus 6 is left over. Okay, I'm going to take out the z plus 1, and then we're left with y minus, y minus 6. Just to show you that as an illustration here, if I just take out the y plus 1, take out the y plus 1, what do we have left? We have a y minus 6 left. Now, if we multiply this back, if I say z times y is zy, z times 6, negative 6z, 1 times y is y, and 1 times negative 6 is negative 6. As you can see, this answer here is our starting problem up here, but the order is just a little different. Okay, the order is just a little different, but it's the same answer. Okay, that's it.